Okay, the next one is the non-metal. For a non-metal, the valency is always determined by the outermost electron. Okay, let's consider oxygen for an example. Oxygen is symbolized as O and the atomic number is 8. So writing it on the shell, it is 2,6. Okay, let's consider nitrogen. Nitrogen is 7 and the atomic number is 7. Writing it on the shell, that's 2,5. Let's consider fluorine. Fluorine is number 9. Writing it on the shell is 2,7. So where is the valence electron? The valence electron is at thermal shell because this is a K shell and this is the L shell. On the K shell of oxygen, we have 6. On the L shell of oxygen, we have 6. On the L shell of nitrogen, we have 5. While the one for fluorine, we have 7. Now, what does this actually mean? Does it mean they are going to give out? No. Non-metal don't give out. Rather, they receive. It's only a metal that gives out, but a non-metal will always receive. So in this case, oxygen is a non-metal and is willing to receive electron. So looking at oxygen, how many more electrons do you think oxygen needed to complete its shell? Recall, I said the K shell can only accommodate the maximum of 2 electrons. The L shell can only accommodate the maximum of 8 electrons. The M shell can accommodate 8 electrons, while the N shell can accommodate 8 electrons. So if the L shell of oxygen is 6, how many left for it to complete 8? That's just 2. That is why you usually see that oxygen is written as 2 minus to tell you that the valency needed 2 more electrons to be gained. But let's consider nitrogen. For the case of nitrogen, the valence electron is on the L shell and that is 5. How many does it need more to complete 8? That's 3. So we have to write nitrogen as minus 3. Let's consider fluorine. Considering fluorine, the L shell is 7. So it needs 1 more. So we write fluorine as F, then put minus 1. So the valency of fluorine is minus 1. That of nitrogen is minus 3. And that of oxygen is minus 2. These are the way we determine the valency of a metal and a non-metal. Okay, talking about a metalloid. A metalloid is also known as semi-metal. The word semi means half. So that means a metalloid is partially a metal. So if it is a partially a metal, it means it's also a partially a non-metal. So a metalloid has the characteristics of a metal and the characteristics of a non-metal. Let's do a fast recap. Recall I said something about metals, that let us assume A was a metal, and you always know that A will always give out electron to turn to A+. But for non-metal, let us assume our non-metal is B. B will always gain electron to turn to B-. So this means that A is a metal because it gives out electron, while B is a non-metal because it gains what? Electron. But for the case of a metalloid bears the two properties at the same time. So it means a metalloid can either give or receive. Okay, let's give a quick example. Carbon. Looking at carbon is number 6. So for this case, if carbon wants to fill in the shell, the K, the M, the L, and the MM. So carbon will fill the K shell with 2 electrons, and the rest of the L electron will be filled into the L shell, which is 4 electrons. Now look at it carefully. The K shell can only accommodate 2 electrons, while the L shell can only accommodate 8 electrons. So in this case, it's either carbon complete its structure by giving out the O4, or complete the structure by gaining 4 to complete 8. So you can see that carbon can either give or receive. So in that kind of case, carbon has 2 valencies. Sometimes the valency of carbon is always written as -2 or +4. So carbon valency is either -2 or +4. As you know, that minus is always used to indicate a non-metal, and +4 is always used to indicate a metal. So anytime we have an element having two different valency, we call them semi-metal or metalloid. Another example is silicon. Silicon is number 14 and it symbolizes as Si. And when we arrange silicon on the KMN shell, we have 2, 8, and 4. Consider the valency, which is on the M shell. It has 4 electrons. So it's either give or receive. So when you give out the whole 4, and when you receive 2. So this is the valency for silicon. So they behave like a metalloid, or you call them semi-metal.